Hello, welcome to Sadhu's lecture on buffers, the acid-bases unit.
Alright, so, a buffer, by definition, is anything that resists a change in its pH. So, resists
change in pH.
Change.
Yeah.
Say it after me, guys.
Explain
okay.
pH.
So buffer is made from a weak acid and the salt of that acid, or weak base and the salt of that base. So let's have an example. So a weak acid would be HF. Right, hydrofluoric and HF.
Isn't that strong?
It's just weak, yeah. So I thought.
It's weak?
Plus the salt of that acid, so that'd be like NaF. So the thing is, if an acid is weak, that means it doesn't totally dissociate. So we could say that HF becomes
it doesn't dissociate.
H plus F minus. But since it's weak, this reaction is in equilibrium. Let's rewrite that as simply that. So it exists in equilibrium, partially dissociates into H plus and F minus. However, since the salt of the weak base isn't itself weak, it can dissociate completely. So you have NaF completely dissociating into Na plus F minus. Okay. So essentially, since it's a weak acid, you have H plus, and if you had the solution of hydrofluoric acid and sodium fluoride, if you try to change the pH, for example, let's say you add more hydrogen ions, like you add HCl or something to it, and that adds hydrogen ions. So H plus ions, the more H plus ions they are, the greater the lower the pH, or the greater the acidity. So if you add hydrogen ions, let's see how it interacts with each of these separate reactions. So if you add hydrogen ions, it interferes with this reaction because there's hydrogen ions implicated in this reaction. So basically, you'd shift equilibrium over to the left side by Le Chatelier's principle, because the equilibrium would want to restore itself. So if you add hydrogen ions to this side, let's say you have an increase in the concentration of hydrogen ions, and so to balance out this increase in concentration, the equilibrium would shift to the left, towards hydrofluoric acid. Now, since it shifted over, but you didn't add any excess fluoride ions, you have fewer fluoride ions present in this entire reaction, but an abundance of hydrogen ions. So to solve this problem, that's where the NaF comes in. So these fluoride ions can go over here, and really the buffer's capability focuses around this equation, the partial dissociation of the weak acid or weak base. It works the same with bases, but and the partial dissociation of this, the effect of an increased pH or decreased pH on this reaction, and the ability of the lower reaction, the salt reaction, to replenish the other, or the anion that's present in this case the fluoride ion. So essentially, you can see from this that we could predict that these buffers would not be totally effective for a huge amount of time. So if we have buffer, if you have the amount of pH increase, so basically, I'm not going to label these axes, but if you're continually adding hydrogen ions to this solution, they would add and add, and it's dependent upon the amount of fluoride that's present. So basically, after a while, this NaF would no longer be able to replenish the fluoride ions that are present in this, that are being depleted by this reaction. And so basically, the buffer would be effective in its buffering capacity, and then it would reach a point where it's no longer able to buffer anymore because of the depletion of this reaction. That's how buffers work.
Jog my memory.
Alright, well that was buffers.